Hello class, in this lesson we're going to learn about arc measures and parallel chords. So how do we measure an arc? Well, we measure them in degrees just like angles. So we know in a whole circle there's 360 degrees, and in a semicircle there's 180. For a minor arc, we say it has the same measure as a central angle, so minor arc AB, 50 degrees. And for a major arc, one way to look at it is to subtract 360 for the whole circle and the corresponding measure of that minor arc. So 360 degrees minus 50 degrees is 310 degrees. Now they're telling us that arc AB is a measure of 20 degrees. What can we say about the measures of arcs CD and EF? Well, you know they must also be 20 degrees because they all have the same central angle. Now you might be thinking to yourself, well, that doesn't make much sense. These are different sizes. Well, be careful. We're not talking about the arc lengths here. We're talking about the measures of the arcs, which are in degrees. So they correspond to that central angle. And that central angle is the same for all three of those arcs. Here we have arcs BC and CD, which are adjacent. And so what do you think would be a good definition for adjacent arcs, given this picture? Well, arcs that share exactly one endpoint. And if we know what the two smaller arcs are, can we figure out the measure of arc BD, the larger one? Yeah, we should just be able to add those measurements together. And that is completely true. We can add adjacent arcs together to get the measure of the larger one. Right? It's very similar to angle addition. So we've already looked at inscribed angles that are acute and inscribed angles that are right when we have Daly's theorem. In this case, we're going to construct one that's obtuse. So put a point B on the minor arc between A and C, draw angle ABC, and then highlight the intercepted arc in red. So try that and I'll show you my diagram. So here's what mine looks like. And we know one way to figure out what the major arc measures is by doubling the measure of the inscribed angle. So let's do that right now. So remember, start at 0 over here. And we end up with 146 degrees. And so if we double that, we get the measure of this central angle, which is going to be the same as the measure of that major arc. So we double 146 degrees and get 292 degrees. Now we also saw previously that we can also find a major arc's measurement by subtracting the minor arc from 360. So we could have also done that. The central angle is 68 degrees, subtracted from 360, 292 degrees. Here they give us an extended ratio. And so we don't know what these measurements are right now, but we know they all have a common factor, let's say of x. So we can fill in these central angles because they have the same measurements as the arcs. So try to solve this on your own, and then I'll show you my solutions. So we know that if we add up all of these together, we get 360 degrees. And we solve this, and we get x is 36. So now we go back and we substitute. So let's see, BAC is 1x, so it's 36 degrees. DAE is 3x, so it's 108 degrees. DB is 4x, right? Because that's going to be the same, for the arc, it's going to be the same as the central angle, 4x. And arc CED, well, that's made up of arcs that measure 2x and 3x, so it has a measurement of 5x, so 180 degrees. Okay, one more example to try on your own, and then I'll show you my solution. So they give us that AB equals CD. And what else do we know about AB? What's special about it? It's a radius. So all of these are the same. So for arc CD, the corresponding central angle is an angle in an equilateral triangle. So we know it has to equal 60 degrees. Let's see, arc CAD. That's a major arc, and we know we can find its measurement by subtracting the corresponding minor arc. So 360 degrees minus 60 gives us 300. And the measure of arc ACD, well, they tell us that AD is the diameter, so it has to be 180 degrees. What do we have in this diagram? Well, we have a circle, we have arcs, we have a chord, we have endpoints. And what do you notice about the chord and the minor arc? What's special about them? Well, they share endpoints. And we say that minor arc AB is subtended by chord AB. So what do you think that means? Well, subtend in this sense means that the chord cuts a circle and it forms that minor arc. They have the same endpoints. And this comes from a corresponding Latin word, which means to stretch underneath. And it looks like that chord is stretched underneath the arc. And from the orientation, it looks like that. We know we could turn the circle and it wouldn't be that, but that's the inspiration behind the word. So what's special about how arc CD is related to chord CD? Well, we can say that the arc is subtended by that chord. And if we know that the chords have the same measure, what can we say about the arc measurements? Well, hopefully we can say those measures are the same as well. And that is true, and we're going to prove that right now. So if we draw in 4 radii here, we end up with these 2 triangles. And they share they have 2 pairs of congruent sides, right? Because the radii are all congruent. And they tell us that AB equals CD. So these triangles are congruent by side, side, side. So we know that the corresponding angles here must be congruent. And these are the central angles for these arcs. So these arcs measure, the arc measures are also equal. You can try exercise 3 on your own, and then I'll show you my solution. So they give us, we can figure out that the measure of this angle is 27 degrees. And they give us over here that these 2 angles are congruent. So this inscribed angle is also 27 degrees. And we know to find this arc length, or not arc length, the measure of the arc, it's going to have to be the same measure as the corresponding central angle. So we double 27 to get 54. What do we have in this diagram? Well, we have a circle again, we have some arcs, and we have parallel chords. That's important. What's it look like is special about the arcs? What do you notice about them? Well, it looks like they're congruent. And in fact, they are. We're going to prove that fact. So to do that, we're going to draw in chord CD. And let's see if we can reason through this here. So what do we have now that we drew CD? Well, we have inscribed angles. And we also have a special pair of angles because these are parallel chords. These are alternate interior, so they're congruent. And so since these inscribed angles are congruent, they have the same measure, and that must mean that the measures of the corresponding intercepted arcs are the same as well. So that's the outline of the proof. Here it is a little bit more fleshed out. And we can't always do this, but we can do all of these steps in the opposite direction. We can prove the converse is true as well. And so if we do that, we can also say that when we have congruent arcs, then they are between parallel chords. So using the previous diagram, I'd like you to try to solve exercise 4. So draw a diagram and see what type of quadrilateral you come up with. Here's my diagram, and this looks like a trapezoid. So since the arcs are congruent, we know that we have these parallel chords. So we have parallel sides, so it is trapezoid. But more specifically, like we proved before, we know that the chords that subtend these arcs are congruent. I'm sorry, we proved the converse of that, but that one's as well true in both directions. And since we have these, the non-parallel sides, or the ones that aren't necessarily parallel, are congruent, then this is an isosceles trapezoid. And finally, exercise 5, try this on your own, and then I'll show you my solution. So for CD, we have, let's see, we have parallel chords. So that means that the measure of CD is the same as the measure of BE. And to get BE, we can just double 65 degrees. There we go, that's 130 degrees. Now for ED, it's a little bit easier if we draw in this side of this triangle here. And what's special about this triangle? Well, one of the sides is a diameter, so by Thales' theorem, we have a right angle over here. Angle BED is a right angle. So that means that these two acute angles are complementary. So angle EBD is 25 degrees. And so the measure of this arc is going to be double that, 50 degrees. In this lesson, we learned about arc measures and parallel chords. Thanks for watching this video.